Hello and welcome to our presentation of a configurator for enterprise architecture visualizations. In this video, we will demonstrate a wizard that empowers end users to dynamically bind visualization types to arbitrary information models. The overall goal of our efforts is to empower end users without modeling expertise to configure visualizations in an ad hoc manner. This builds the foundation for complex visual analysis of EA information. This is a wiki-based repository called HybridWiki. In addition to plain text information, it incorporates also structured information. The information model is flexible and end users may define new concepts from scratch. This way, HybridWiki empowers to define an arbitrary information model for EA management. In this demo, we use an Archimate information model to show visual analysis of respective instances maintained in an EA repository. In HybridWiki, EA visualizations can be integrated in any wiki page. We just hit the Edit button on a wiki page, which fires up an editor for a wiki page. Within this editor, we can insert an EA visualization by clicking on an icon. This opens a wizard for configuring EA visualizations. The first step is to choose a visualization type. A preview and explanation for each visualization type is provided. Moreover, information of typical user scenarios is given. In the next step, the binding of the information model is specified. Here, we employ structured pattern matching techniques to propose valid configurations for the chosen visualization type to the end user. That is, the structure of the information demand from a visualization type and the structure of the information offer from an EA repository are matched with each other. The result of the structural model match is then shown to the end user. To generate an EA visualization in a model-driven manner, the end user has to specify a detailed binding to the information model. Often, sophisticated scripting or query languages are employed to provide this mapping. In contrast to those approaches, we provide our matching results in an end-user-friendly user interface. In this example, we choose the information model elements that are used for rows, columns, and cells. In addition, we choose references to be traversed to get from rows to cells and from columns to cells. Our pattern matching algorithm also takes into account transitive relationships. To configure these properties, the end user does not have to fully understand the EA information model. Also, the end user does not have to learn a scripting language or to be a model expert. On configuration changes, our user interface is responsive and shows an updated preview of the actual visualization. This way, the user gets immediate feedback. In addition to just binding an information model, respective data can be also filtered. In the next step, visual parameters can be configured. This includes, for instance, border colors, shapes, size of those shapes, and other variability points specified by the visualization type. After getting the last preview to see how our changes look like, we can finalize our visualization. This is now inserted into the content area of the wiki page we just edited. We may add some descriptions here or add additional images. After saving the page, the visualization is now dynamically created each time the wiki page is displayed to the user. Users can look at the visualization using basic navigation mechanisms or even download the visualization as a PowerPoint presentation. This way, enterprise architecture visualizations that are very likely to have large amounts of elements on it can be edited manually and included in a presentation to make a certain point during a presentation in front of the management board. I hope you now got an overview of our visualization framework, the application of structural pattern matching techniques for complex model bindings, and the ad hoc configuration and generation of EA visualizations. Thank you for your attention and goodbye.